Welcome to section 5.1, which is on integers. So we're going to talk about what an integer is, start there, and then we'll get into some problems that involve integers. So an integer is just a positive and negative whole number. So positive and negative whole number. And then let's list some of those out. So there are infinitely many integers, so we can't list out all of them, but we can list out a few. So like -3, -2, -1. Remember that whole numbers is the set of numbers including 0 and then increasing from there. So basically like counting numbers. So integers just are those numbers and the negatives of those or the opposites of those. So what is an opposite? So I use the word opposite. Opposite is just when you change the sign of a number. So it's a sign change. So the opposite of -14 is 14. The opposite of 8 is -8. Now 0 doesn't have a sign, so if we were to take -0, for example, if you were to even do that in your calculator, you would just get 0. So 0 doesn't have an opposite, it just stays 0. So where are integers used in the real world? So there's a lot of different places we see integers, but here are a couple of examples, like credits and debits. So like if you were to list out on your credit card statement, for example, you could list out all of the credits, or a minus anywhere you spent money and a plus anywhere you were to deposit money, or like a bank account would be probably a better example because you don't usually deposit money in a credit card. Elevation, altitude is a great example. So if we think of sea level, okay, as 0, anything below sea level is negative, and anything above sea level is positive. Okay, temperature, we all know we've seen temperatures, especially in Michigan here, drop below 0 before when we use negatives. And then sports, that's a great one too. So with kids, you can use football examples where, the center of the field, you think of that as sort of the 0, and forward is positive and backwards is negative depending on where the ball is. So you can come up, there's lots of fun games online that use negative and positive numbers to do games for kids. With sports. So let's do a couple of examples. So example 1, and this picture comes from our textbook. Determine whether the U.S. trade balance with Turkey was positive or negative at the following times and interpret the results. So is it positive or negative? And then let's interpret the results. So 2004. So see if you can figure out what the trade balance would be in 2004, and then let's interpret those results. So it looks like in 2004, and it's negative because this line here, you can see it's in red. This is where 0 is. So anything below that line, so this line here is in red because it's underneath 0. So I'm going to say negative. And then interpret the results. So what are those results? It looks like if we go across there, it looks about -2,000. And interpret, in order to interpret that number, let's look at the y-axis label. So it says millions of dollars. So what does -2,000 million mean? So first let's make it a million by adding 6 zeros. Okay, so if we add 6 zeros, then we actually get $2 billion. So this would be 2 billion in debt. So we owe them $2 billion. And then let's do the same thing for 2009. So if we look at 2009, it looks like we're right here. And then if we look across, a straight edge would be nice here, but you just do your best. So it looks like it's about 3,500. And again, this is in millions. So if you want to make it a million, you just add 6 zeros, and then it looks like about 3,500,000, and it's positive. So that would mean that we have a positive balance with Turkey. So we don't owe them money. They owe us money. For example 2, we're asked to determine whether the U.S. trade balance with Turkey was increasing or decreasing. So let's just talk about how we can tell if something is increasing or decreasing by looking at a line graph like this. So anytime the graph is going up from left to right, we've got an increase. And then anytime it's going down from left to right, we've got a decrease. Okay, so from 2002 to 2004, let's see what happened. So it looks like 2002 is right there, 2004, it looks like it is decreasing. From 2004 to 2006, looks like we've got an increase there. And then from 2008 to 2009, looks like we've got a decrease. All right, so let's go to example 3. Winter temperatures in Antarctica are usually below -100 degrees Fahrenheit. What is the lowest, coldest of the following temperatures? And we've got some choices there. So just remember, you can always think of a number line. So I always have, when I used to teach this in 7th grade, I used to draw a number line, and let's just visualize. So if this is 0, where would -119 be? So if let's say -119 is right there, well, where would -98 be? Okay, it would be closer to 0, and I'm not drawing this to scale, but the idea here is just to basically order the numbers. Where would -110 be? Maybe it's right there, so -110. Where would -114 be? Maybe right there. And where would -108 be? Maybe right there. So next time I'll draw a bigger number line. But basically you get the idea. So what is the lowest temperature? Well, it'd be the biggest, it looks like the biggest number, but since it's negative, it's actually the smallest number or the lowest temperature. So we'll say the coldest temp would be -119 degrees. Oh, and you know what I'm seeing? Oh, you know what? This negative should go with this 114 there. There we go. And actually, while I'm at it, and I should have mentioned this in the beginning, what grades are we going to be covering integers in? So in the 6th grade, Common Core Standards, students are asked to understand the concept of integers, a positive and negative number. And then from 6th grade on, integers are part of the Common Core Math standard. So, but just because it's a 6th grade standard does not mean you can't introduce it earlier. And I think kids are definitely ready as early as even 2nd or 3rd grade to understand the concept of a negative number. So just because it's in 6th grade doesn't mean you can't start it sooner. All right, let's check out example 4. So at -40 minutes in the countdown, so that would be like 40 minutes before the countdown for space shuttle launch, the technicians began a 7-minute check. What was the time in the countdown at the end of this check? So this would be a great place. Pause the video, maybe draw a picture. So we've got -40 minutes. Okay, that just means 40 minutes before the launch, and they did a 7-minute check. So 7 minutes goes by, so we would be at 33 minutes before the countdown. So, and the way we would write that if we wanted to do a math sentence would be we'd take -40 and we'd add 7 minutes and we get -33. All right, last example. A submarine has an altitude of -5,000 feet. So what does that mean? So think of sea level as here, and if the submarine has an altitude of -5,000 feet, it means it's 5,000 feet below sea level. So we'll think of the submarine right here, so that would be -5,000 feet. It dives down an additional 1,500 feet, so it'd be even further below sea level. So 5,000 plus 1,500 would be 6,500 feet, and it would be negative because we're going down even further. So the altitude would be -6,500 feet. Okay, so let's get into how you can use some models to actually add and subtract negative and positive numbers. So one model is called the chip model, and you can use actual chips in the classroom, which are great, and you can also use colors on your paper, red and black. So you could use, one red and one black, you know, you can draw them like that. The other way to draw them too would be to just use pluses and minuses. So instead of red, you could just draw a minus sign, and then black would be a positive, and you could draw them like that in case you don't have the different colors or don't want to bother with them. So the main idea though is if you combine one red and one black, or one negative and one positive, you're going to get 0. It's kind of like saying 1 plus -1 is equal to 0. They cancel each other out. So that's the main idea. So as we're going through, we're going to look for those to cancel each other out. So addition. If we want to do -5 plus a +2, we could do -5, 1, 2, 3, 4, 5. So 5 negatives, 2 positives. And then what we would do is we'd say, okay, well, these cancel each other out because a positive and negative makes 0. These cancel each other out. And then we're left with 3 negative chips. So our answer is -3. And it's negative because we have more negative chips. So when you have more of a certain kind, that sign wins out. So the next one, we've got just negative numbers. So we've got 4 negative, and we've got 3 negative. We don't have any canceling because they're the same sign. Together we have -7, so 7 negative chips. The next one, it looks like we've got 7 positive and 2 negative. And then you can go cancel the pairs out that are a negative and a positive. And then left over, we've got 5 positive. So our answer is a +5. So notice the difference between the first one and the third one. The third one, the answer is positive. The first one, the answer is negative. It's negative in the first one because the bigger of the two numbers, well, if you ignore the signs, the bigger of the two numbers is negative, so that wins out. And over here, there's 7 is the bigger of the two, so the positive numbers win out. So let's look at how you would use chips to do subtraction. So the takeaway method. So for a younger grade, they might do a problem like this where you have -6. And then what this means right here, it means to take away. So the subtraction means take away 2 red chips. So take away 2 negatives. So you'd say, okay, well, I'll take away 2 negative. And then what am I left with? I'm left with -4. That's my answer. Okay. That's not so bad when you have a problem like that. But check out the next one. The next one is a lot trickier. So if you start with 3, what this says right here is to take away 5. The problem is I don't have 5 to take away. So this is what you can do. It's like a little trick, and this is a great visual for why 3 minus 5 is the same thing as 3 plus a -5. So we could switch it like that, but I'm going to show you how else you could look at this. So, oh, and you know what? I'm writing this down below. That's okay. We'll come back to this. So, I should have been writing it up here, but I'm writing it down below. But I'll keep writing it down here, and then I'll go back and fix the last part. So we've got 3 positives here. It says to take away -5. I don't have 5 to take away, or I'm sorry, not take away 5 positive. So what I'm going to do is I'm going to add 2 more. Then I have 5 there. The problem is I'm not allowed to just add numbers. I can't change the problem. So what I'm going to do is I'm going to compensate by adding 2 negative as well. Because if you think about it, what is this equal to? 2 positives and 2 negatives, that's really just equal to 0. So I'm not changing the number at all. I still have 3 here plus 0, but I have some positive chips that I'm able to take away. Okay, so I'm going to erase this. So now what I'm going to do is I'm going to take away the 5 positive chips. So I'm going to go 1, 2, 3, 4, 5. And then what do I have left? I have left 2 negative. Okay. The other option here where it says adding the opposite, and I'm just going to write it above, is we could say 3 plus a -5. And the nice thing about adding the opposite is we can just say, okay, well, here's 3 positive and here's 5 negative. We'll cross off the pairs, and then we're left with a -2. Okay, that's way simpler. I'm sure you're thinking this already. It's way simpler than this other method that I showed you down here, but it's nice to know that both of these different methods exist, because a lot of times you'll get students, especially the smarty pants ones, that are, ask questions like, well, why does adding the opposite work? And you can show over here that you have to end up adding those two negatives in order to take away 5 positive. And then let's go through and we'll do this one too. So -4, so I'm going to draw -4. And then what this says here, it's subtraction, so that means take away. And if it's -8, take away 8 red. Well, I don't have 8 red to take away. So I'm going to add another 4 in so that I have 8 to take away. But I'm going to compensate that by adding 4 black ones as well. So remember, all of this here, this is just 0, what I just added. So that was in addition. And then now I have 8 to take away. So now I can say, okay, well, I'll take away 8 red, because now they're available to take away. And then what's left over? 4 positive. Okay. Or you could add the opposite by taking -4, a negative and a negative is a positive, plus a positive 8, and you end up with a positive 4 that way. So a little bit simpler, but you've got some options there. So let's talk about some rules for adding and subtracting if you were to not use the chip method. So the chip method's great to introduce this, but we all know, I mean, once numbers get bigger, it's probably not realistic to be drawing that many chips out. So how do we approach these problems? So step 1, you're going to turn all subtraction problems into addition by adding the opposite. So for example, like in example 6, 7 minus 15 is going to change to 7 plus a -15. And then same thing with this one, -14 plus a -3 and -22 plus 5. Then once we change all subtraction into addition, we can go through these following steps. So if we have a positive plus a positive number, we're going to get a positive answer. So we know that already. If you have a negative number plus a negative number, okay, so for example, if we had -3 plus a -5, that would be like 3 red chips and 5 red chips. All you need to do is add how many chips you have. So you're going to take the numbers, 3 plus 5 equals 8. And then make your answer negative. So a negative plus a negative is always going to be a negative, and you're just going to add the numbers and then make the answer negative. Okay. And then a positive plus negative, this is going to depend. So it depends on the problem. So let's look at our examples above. So if we look at our examples above, let me just scroll up here. So in this case right here, 3 minus 5 or 3 plus a -5, we end up getting a negative answer. -4 plus a positive 8, we end up getting a positive answer. Well, why do we get a negative answer with this first one? Well, if you look at the picture with the chips, we have more red chips than we do black, so red wins. In this example, we have, or you can look at it down here, we end up having, actually, you know what I'll do is I'll just draw it right here. If you have 4 red chips, and then you have 8 black ones, after you cross them off, you end up having more black left over, so the black wins. So it depends on, if you ignore the signs, it depends on whatever number's bigger. Whichever one, ignoring the sign, whichever number is bigger in the problem, the answer is going to take on that sign. So positive plus negative, it depends. The answer will take the sign of the larger number, and that's if you ignore the signs. So ignoring the signs for a minute, if you just look at the actual numbers. So for example, 7 and 15. 15 is bigger, and that's negative, so the answer will be negative. With this one, they're both negative, so the answer is going to be negative. With this problem, -22 is bigger than 5, and that's negative, so the answer will be negative. Okay, now we've talked about the signs. How do you get the actual answer? So for number 4, we are going to look at whichever number is bigger to tell the sign, but what you're going to do is you're going to find the difference between the two numbers. So you're going to take the bigger number and you're going to subtract the smaller one. Okay, so for example, 7 plus negative 15, we're going to do 15 minus 7 equals 8, and then we're going to make the answer negative. So the answer is negative 8. Okay, I want you to visualize 15 red chips and 7 black chips, and we're going to end up canceling 7 of them, so there's 8 left over. That's why we're wanting to find the difference, and the ones that are left over are negative, so that's why the answer is negative. With this one, they're the exact same sign, so we're just going to do 14 plus 3 is 17. We're going to make the answer negative because both of these numbers are negative. And then with this last one, so our answer is going to be negative because that's the bigger of the two numbers. And then we're going to take 22 and subtract 5, and that's going to give us 17. And then we're going to make our answer negative, and we get negative 17. Okay, so now let's talk about some multiplication and division. So this first one, the number line model, I actually copied this right out of the book. I think the number line model works great for 4 times 3. It works great when you have a positive times a negative number, like 5 times negative 2. I don't think it works that great with the last two, and I'm going to actually just cross those off. I think it's more confusing than it's worth. So I wouldn't even bother using a number line for these ones, but I think it's worth it for 5 times negative 2. So 4 times 3, what does that mean? You're starting at 0, and this means you have 4 groups of size 3. So it means you're going to go up to 3, and then you're going to go another 3, and then you're going to go another 3, and then you're going to go another 3, and you're going to land at 12. So you're going to go to 3 4 times. This one says you're going to go to negative 2, and you're going to do it 5 times. So 5 groups of negative 2. So starting at 0, you're going to go to negative 2, and then another negative 2, another negative 2, another negative 2, and another negative 2, and you're going to land at negative 10. The problem with these next two is if we interpret the first number as how many groups you have, well, if the first number is negative, how do you interpret negative groups? One way is you could just go in the opposite direction, okay? So you could end up, instead of going positive or up 2 groups, you could go down 2 groups, which isn't too bad. With the last one, I think it gets confusing because the negative here, if you were to go down 4 groups of negative 2, you'd have to end up turning around and going the opposite way. So again, I think for those last two, I wouldn't even bother with the number line. I think with chips, I think can make a lot more sense. So this first one, this first number we can represent as the number of groups. So number of groups to add, okay, add because it's positive. And then what is going to be in each group? We're going to say 3 red chips. So the way we're going to draw this picture is we're going to say we're going to have 2 groups of 3 red chips, so total we have 6 red chips, or negative 6. For this next problem, this minus, you can kind of interpret this as take away 2 groups of 3 red chips. Now, the problem is we have nothing on the paper. So how do you take away 2 groups of 3 red chips if nothing's in front of you? Well, we can do that little trick that we did on the first page where we kind of make the groups. So what we can do is we can make 2 groups of 3 red chips so that we have them to take away. But the problem is I'm not allowed to just add things. So to compensate, I'm going to put 3 blacks. So basically we're just starting out as 0, okay? And now we can take away 2 groups of 3 red chips. So I'm going to say take away, take away, take away, take away, take away, take away. And we're left with 6 black chips, or 6 positive. So that's one way to show that a negative times a negative is a positive. If you're looking at this thinking, whoa, like that doesn't make any sense, it's one of those things where you have to do several times before it starts to make a little bit of sense. And then even then, it might not sink in because it might not be the best way to get this across to you. And that's okay. Another option is to use patterns. So we can look at these multiplication problems below, like 3 times 4. So I'm just going to start writing down these answers. And if you look at what's happening is, so this first number is decreasing every time we go down. So 2 times 4 is 8. 1 times 4 is 4. 0 times 4 is 0. So what's happening to these answers? Every time we go down a row, we're subtracting 4. Well, if we were to continue that pattern, what would happen? 0 minus 4 is negative 4. So just continuing this pattern with multiplication, we end up getting a negative answer. And look at the problem, we've got a negative times a positive. And then if we continue the pattern again, minus 4, we're left with minus 8. So a negative times a positive ends up giving us a negative answer. So we're just using this pattern to show that it's going to eventually need to be negative when we start decreasing those numbers that we're multiplying. And then let's look at the pattern over here. So in it's a little bit different of a pattern. So we start with a negative 2, and then these numbers on the right are decreasing. So negative 2 times 4, we just said was negative 8. Negative 2 times 3 is negative 6. Negative 2 times 2 is negative 4. Negative 2 times 1 is negative 2. So what are we doing here? Every time we go down, we're adding 2. We're adding 2. We're adding 2. Negative 2 times 0 is 0. Anything times 0 is 0. Well, what happens if you have a negative 2 times a negative 1? Well, if we use our pattern, we're going to have to add 2. So a negative times a negative is equal to a positive answer. And then since multiplication and division are essentially inverse operations, meaning like 4 divided by 2 is the same thing as 4 times 1/2. Okay, those are the same thing. You end up getting 2 in either answer. Then the rules for division are the same. So negative divided by a positive is a negative answer, and then a negative divided by negative is a positive answer. Okay. There's a couple of different ways we can use chips to show division. So there's 2 methods. We've talked about these before in section, I think that was 3.4. So the sharing method is when you start, so we're going to start with the first number and we're going to divide into 2 groups. So the second number is the number of groups, as opposed to the measurement or subtractive method means this is what you will subtract. So 2 different ways to look at division. So notice that this problem, the second number is positive, so it lends itself well to the sharing method because it makes sense to have a positive number of groups. Whereas if you were to look at this one, you might think, well, how would I do the parative? Because how do I have a negative 3 number of groups? So that's why the subtractive method makes more sense in that example. So with the sharing method, we're going to start with 8 red chips. And then this tells us to make 2 groups. And then the answer is what's in each group. So there are negative 4 in each group. So the answer is negative 4. And then negative 6 divided by negative 3, the way we would do this with the subtractive method is we would start with 6 red chips. And then we would subtract, and this should say, that's actually a typo, that should say red. We should subtract 3 chips as many times as we can. So you take off 3, I did it once, and then I did it twice. So I do it twice, so the answer is 2. Okay, so same concept as what we learned in 3.4, we're just using negative numbers instead of positive numbers. All right, so we've got one more page. Let's check out the next page. So we're going to talk about some inequality signs and properties, and then some mental calculation and approximation. So with inequality, so we're trying to order these numbers. So how could we do this with students? You could have them put these on number lines. Okay, might be a good idea. I think a human number line is always fun too. You can make a number line on the floor with tape in your classroom, and you can have students stand where they think the negative 37 might be, a negative 55, and they could even estimate. So you're not spending a whole lot of time making number lines that are this big. But so which number is bigger? So negative 55 is going to be the smaller of the 2 numbers because it is more negative. So this is farther from 0. Okay, just like over here, 420 is going to be bigger because that's closer to 0. Negative 125 is farther from 0 than negative 176, so negative 176 is going to be greater than that. All right, so let's check out these properties. So these are very similar to the properties that we talked about for whole numbers. We're going to go back and talk about them in terms of integers. So integers we say are closed under addition and multiplication. So you can multiply two integers and always get an integer. So for example, if you were to do negative 10 times negative 2, you end up getting 20. All of those numbers are integers. You're never going to get like a fraction or decimal if you take two integers and multiply them. Same thing with adding. If we were to add negative 10 plus a negative 2, we end up getting negative 12. Now, that doesn't prove it, but those are just some examples. Now, division and subtraction are not closed because if you were to take 10 and 2 isn't a good example, because if I took those and divided them, you would actually get a whole number. But I could do it the other way around. I could do negative 2 divided by negative 10, and I would end up getting 2/10 or 1/5, which is not an integer. So division is not closed, we say. Subtraction isn't either. And actually, you know what? I take that back. Nope, subtraction is closed because if we have any integer and we subtract it, you're going to get an integer. So that, I should have added that. So for example, if you take negative 10 and you subtract, it doesn't matter what you subtract, you could subtract anything. If you subtract 2, you're going to get negative 12. So subtraction wasn't closed for whole numbers because if we were able to get a negative, then that kind of threw it off. But in this case, negatives are allowed. So I'm going to also say an integer minus an integer is equal to an integer. Okay. Commutative property. So that means we can switch the order. So A times B is the same thing as B times A. A plus B is the same thing as B plus A. Associative property. We can notice A, B, and C, A, B, and C. So we've got the same order of numbers, but the parentheses are in different locations. So for example, negative 5 plus negative 3 plus 2 is the same thing as negative 5 in parentheses plus negative 3 plus 2. And you could do the same thing for multiplication. The identity property. So think of the word identity. Identity, if you want to keep your identity, it means you want to stay the same. So you want to keep yourself. So identity in terms of numbers means what can we do to it so that the number remains the same. So with multiplication, we can multiply the number by 1. So 1 is the identity for multiplication. For addition, 0 is the identity, the additive identity, because it allows a number to stay itself if you add 0 to it. The additive inverse, so this is different. So the additive inverse is the number that you can add to any number so that you get the additive identity, 0. So 5 plus negative 5 is going to equal 0. So these two numbers we say are additive inverses. So 10 and negative 10 are additive inverses. 100 and negative 100 are additive inverses. So the opposite of any number is its inverse, additive inverse. A multiplicative inverse, though, is different. So in order to get a multiplicative inverse, it's the number that when you multiply that number by itself, you end up getting 1, which is the multiplicative identity. So think, what can I multiply 5 by so that I get 1? Well, the only way to get 1 is if you multiply by 1/5 or the reciprocal. So if you take any integer and you multiply it by its reciprocal, you're always going to get 1. So another example might be, I don't know, negative 3. Well, the reciprocal is 1 over negative 3. If you multiply these by each other, you end up getting 1. So the multiplicative inverse is just the reciprocal of the number. And then distributive property, we've talked about this before. This is no different. It's just now we're including negative signs. Negative 5 times 3 is negative 15. Negative 5 times negative 2 is a positive 10. If you add those together, so negative 15 plus 10 is negative 5, you should get the same thing as if you multiply these. So 3 plus negative 2 is 1, and then you get negative 5 that way. And we're doing this not to make it shorter, because it was actually probably shorter to just do the problem as it was in the beginning. But it's helpful to know this just in case down the road, maybe you have a problem like this, where there's an x, and you cannot combine the inside. You have to use the distributive property. So it's nice to know that that also works with integers. Okay, so the next part, mental calculation. So just like the last couple sections that we've done, we talked about just some mental strategies on adding and subtracting. You can use some of those same strategies for integers as well. And the strategies that I'm going to offer are not the only strategies you can use. These are just, some methods that just, came to me when I first did this problem. So for example, 180 plus a negative 37. If I had to do this in my head, the quicker way for me to do this, rather than think, okay, 180 minus 37, is I would probably just do 180 minus 40. That's faster. And keep in mind, 180 minus 37 is the same thing as plus a negative 37. So what I would probably do is just subtract 40, because that's easier math. So 140. And then I would alter my answer. I would compensate for my adjustment. So if I took away too many, so what I did is I took away 3 too many. I took away 140 instead of 30, or I took away 40 instead of 37. So then what I would do is I would just add 3 to compensate at the end. Okay, written out, it looks more complicated, but when you do this in your head, it's actually simpler. So for this one, what I would do is I would probably negative 6 plus 19. I would try to make that 19 probably 20. So and you could even switch it around if you wanted to. So if you wanted to write this 19 minus 6, if that was simpler, you could also do that. And instead you could do 20 minus 6 instead. And then you end up getting 14. But the problem is you added 1 here. So you went from 19 to 20. So to compensate, you're going to have to subtract, and you end up getting 13. And if at any point you're thinking, gosh, this sounds so much more complicated than actually just doing the problem, then you can just do the problem. There's nothing that says you can't. The goal is just to be open to different strategies in case it is simpler. For this division problem, I always like to write it down like this vertically so we can see it this way. Think of it almost like a fraction. With division, you can divide these numbers by a common factor if they have one to make it simpler. So if you divide these both by negative 3, you end up getting negative 50 divided by 2, which is negative 25. Now you might have looked at the problem and already known, like, I mean, negative 150, think of it as $1.50 divided by 6 is a quarter. So you could do it that way and not even make an adjustment, but this is an option. And then for this last one, I kind of debated, like, do you make the negative 5460? But then I feel like you're still, 6 times 12 is 72. You could do it that way. I think probably the simpler way is just to make that a 10. So you get negative 540. And then you need 12 groups of negative 54, and we only did 10. So you need 2 more groups of 54. So you could add 54 twice, or you could add a 108, which is 54 times 2, and you end up getting 648. And it's negative because both these numbers are negative. So these directions says do each computation mentally using a convenient substitution, whereas the next set of directions say obtain approximations, which this is just telling you to round. So your answer does not have to be exact for these. So for these ones, we're just looking for numbers that might work well together. So that's about 100, 80 and 20-ish, okay? Maybe round this to 30 and 50. So negative 30 and negative 50 would be about a negative 80. So 100 minus 80 gives us about 20. And you don't have to round like me. You could have rounded those differently and that would have been totally okay. Like you could have done 30 and 45 would have been fine. This one, that's close to 50 and that's close to 2. So negative 50, whoops, let me back up and make sure I've got the right sign there. So negative 50 and negative 2 give a positive 100 times 142 give us 142 and 2 zeros. So and that's approximate. Awesome. So I hope that made some sense. If not, as always, make sure you ask if you have any questions.